Dear students, a very good morning to you all. In the last class, we have solved exercise 2.1 under the chapter whole numbers. Let us move to the next topic in today's session. Today's topic is properties of whole numbers. When we look into various operations like addition, subtraction, multiplication, division and etc. on numbers, we notice several properties of whole numbers. These properties help us to understand the numbers better. Moreover, they make calculations under certain operations very simple. Let's begin the properties of whole numbers. So the first property is closure property. Closure property, this is the first property. Fine. First property of whole numbers is closure property. See what this property says. Whole numbers are closed under addition and also under multiplication. What is whole numbers? Whole numbers are the set of numbers which begins from 0. Okay, 0, 1, 2, 3, 4 and so on up to infinity. These are all whole numbers. So closure property states that these whole numbers are closed under addition and also under multiplication. So let us see with some examples. Let us consider any two numbers. For example, so any two whole numbers. Okay, for example, I'll take 7. 7 is a whole number, right? Because it comes in this set. The numbers which begins from 0 are the whole numbers, and the numbers which begins from 1 are the natural numbers. 7 is a natural number and also a whole number. So 7, I'll take one more number, that is, let me take 8. Okay, 8 is one more number. 7 is a whole number, 8 is also a whole number. Let us see if we add this both, what will be the answer. So 7 plus 8. What is 7 plus 8? 7 plus 8 is 15. So whatever the answer you get here, it is also again a whole number. Fine. This is also a whole number. 7 is a whole number, 8 is a whole number. When you add both of this, you will get an answer. That answer is also a whole number. This indicates that the whole numbers are closed under addition. So closure property states that the whole numbers are closed under addition. Let me take one more example. See here 0 is a whole number, right? Let me take 0. One more whole number, I'll take 9. Okay, when we add both the numbers, that is both the whole numbers, 0 plus 9 is 9. Again 9 is a whole number. So closure property satisfies here. Fine. So under addition, one more they have given, and also under multiplication. Let us see the closure property, how it satisfies under multiplication. So again, let me take one number. I will take 7. Again 7 is a whole number. Let us multiply with another whole number, 8. Fine. What the answer you get? 7 8s are 56. Right? 7 8s are 56. See, 7 is a whole number, 8 is a whole number, and the answer what you got, 56, is also the whole number. Fine. This is also whole number. Closure property satisfies under multiplication. When you multiply any two whole numbers, you will get the product. That product is also a whole number. So this property is called as closure property of multiplication. And when you are doing addition, this is called closure property of addition. Let us take one more example. Let me take one whole number 5. You can try with other examples also, okay? Another whole number, let me take 6. Fine. When you multiply this, 5 6 30. Fine. 5 is a whole number, 6 is a whole number, and the answer you got 30. This is also a whole number. So this satisfies the closure property of multiplication. Now the question arises, will it satisfy the subtraction and the division? Let us see. So here in the property itself they have given that whole numbers are closed under addition and also under multiplication. Here they have not mentioned about subtraction and division, which means it does not satisfy the property. Fine. Let us check out. See, when you are doing subtraction of any two whole numbers, let me take example. First whole number 6 is a whole number. When you subtract another whole number, that is 2, you got the answer 4. So 6 is a whole number, 2 is a whole number, 4 is also a whole number. In this case, it satisfies the closure property. But let us take another example. See here, 2 minus 6. When you subtract 2 minus 6, what is the answer? 2 minus 6 is minus 4. Okay, minus 4. And this minus 4 is not a whole number. Okay, it is not a whole number. So in this case, in this condition, it does not satisfy, the subtraction does not satisfy the closure property. Hence, subtraction is not applicable for closure property. In the same way, when you take an example for division, okay, division, an example for division. So 6 divided by 2, 6 divided by 2 is 3. So 6 is a whole number, 2 is a whole number, 3 is also a whole number. Here it satisfies. But if the question is like this, 2 divided by 6, since 2 is a smaller number, you cannot divide 2 from a bigger number 6. You can keep it as 2 divided by 6. And this 2 divided by 6 is a fraction and it is not a whole number. Okay, it is not a whole number. So division also does not satisfy the closure property. Fine. So let us see once. So closure property clearly says that whole numbers are closed under addition and also under multiplication. Remember this. Fine. Let us move to the next property. And the second property is commutative property. See, just like the closure property, in the commutative property also, the whole numbers are commutative under addition and multiplication. Let us see what does this commutative property actually says with an example. Let us see the addition of let us see the commutative property under addition. So the commutative property says when you add any two whole numbers, okay, in any order, in any different order, you will get the answer, and that answer is also a whole number. See, I will give an example. let me take an example. 5 is a whole number plus 3, since we are doing the commutative property under addition, so plus 3. 3 is also, what is 3? 3 is also a whole number. You will get the answer 5 plus 3 is 8. Fine. When you add these two numbers in the reverse order, that is 3 plus 5, what the answer you get? Does the answer changes? No. 3 plus 5 is also 8. Means these both are equal. 5 plus 3 is equal to 3 plus 5, as the answers are same. So this is the commutative property of addition. So when you add any two whole numbers, two or more whole numbers in any order, you will get the same answers, and that answer belongs to whole number. So that is the commutative property. Let us take one more example. I will take 80 plus 9. Okay, 80 is a whole number, 9 is a whole number. You will get the answer 80 plus 9 is 89. 89 is also a whole number. Correct? When you add these two numbers in the reverse order, that is 9 plus 80. 9 plus 80 is also 89, and 89 is a whole number. Can you see the answers? 89, this is also 89. 80 plus 9 is 89, and also 9 plus 80 is 89. Both are equal, only the order of the numbers has changed, but the answer you get the same. So this indicates that the commutative property is satisfies under addition. So under addition, let us see with the multiplication. Okay, let us see under multiplication. Let us take these two examples itself, this 5 and 3. Since we are doing multiplication, you have to multiply. 5 into 3, 5 3s are 15. Also, when you change the order of this, 3 into 5, 3 5s are 15. So 15, here also 15. Hence, these both are equal and the answers are same. So it satisfies the commutative property. Take one more example. 3 2s are, so 3 2s are 6. Also 2 3s are, when you change the order of the numbers, here 2 has come first, right? Here it was last, now it is first. 2 3s are 6. Answers are 6, here also 6, right? Products are same. Products are same even though if you have changed the orders of the numbers, that is multiplicand and multiplier, you have changed the positions, then also the answer you have got the same answer. So both are equal. It means it satisfies the commutative property under multiplication. Fine. And just like the closure, under the closure property, here also the commutative property does not satisfy under subtraction. See, for example, when you are doing subtraction, let me take two examples. 3 minus 2. Okay, 3 minus 2, what the answer you get? 1, right? 3 minus 2 is 1. When you change the order of these two numbers, that is 2 minus 3. So 2 minus 3 is, what is the answer? 2 minus 3? It is minus 1. And 1 and minus 1 are not equal. This is the symbol which represent not equal. Fine. Hence, this does not satisfy the commutative property under subtraction. Fine. Take one more example. 5 minus 3. Okay. 5 minus 3 is 2. When you reverse the order of it, 3 minus 5 is minus 2. 2 and minus 2 are not equal, hence it does not satisfy the commutative property. Just like the subtraction, division also does not satisfy the commutative property. For example, 14 divided by 7. So 14 divided by 7 is 2. And when you reverse this order, 7 divided by 14. Since 7 is smaller than 14, you can write it as 7 divided by 14. What the answer you got here? 2. And here it is 7 divided by 14. And these both are not equal. Hence, the commutative property does not satisfy under the division. I hope you enjoyed this session. In the next class, we will be studying about other two properties of whole numbers. Till then, take care. Thank you.